So in the last problem, I said do simplex method like normal, and I wanted to just pick up from where we left off and kind of show you guys. I have it loaded into our little pivot calculator website, and we're gonna just figure out our pivots like normal. I'm gonna work from the pivot website for the most part. I'm not gonna copy it down into OneNote anymore until the very end. But I want to point out. All right, so we're looking here at our objective row, and I'll just kind of put this as a reminder. This is the objective. All right, so now we're going to look for our most negative number, which is the Q column, and the ratios would be 1 divided by 1 or 1 divided by 2. So we're going to pivot right there. Integers. There we go. Okay, so we pivoted there and we got this. Now, we look at our objective and say, are there still any negative numbers? And yes, there are. And we got that. So we have the -2 and the -1. That's bigger. So 1 divided by 3 or 1 divided by 1. Well, 1 divided by 3 is larger. So we're going to pivot on that selection. And you'll notice we still have a negative value here. So now we're going to look. And this is why I wanted to do this with you guys. You see, we have a tie. 1 divided by 1 and 1 divided by 1. So if I pivot on the first selection, you'll see we are now finished, right? And our values here are, I want you to just pay attention really fast because it's going to end up being important in a minute. Do you see we have 2, 2, 1, 4? Okay, when you learn how to read your answers in just a second, you're going to learn that the answer would be x is 2, y is 2, and the p-value is 4. I'm going to undo, and I'm going to pivot in the other spot now. And now you'll see we have different values. The x is 1, the y is 3, and the p-value is 4. So we just had two different answers, and those were, I'm going to write those down. And so just as a refresher, one pivot gave us x equaling 1, y equaling 3, p equals 4, or c equals 4. I apologize. It's a c, not a p. And then the other one was 2, 2, and 4. So is that okay? We have two different answers. And I wrote our objective equation, our original objective equation off to the side to just kind of remind you what we're talking about. Our original goal was to minimize c equals x plus y. So therefore, you'll notice if I were to substitute in 2 and 2, 2 plus 2 makes 4, or 1 plus 3 makes 4. So this problem actually has two different solutions. So don't just assume that because, if WebAssign quote unquote marks you wrong on doing a problem, don't assume you did it wrong. You may have just gotten to an alternate answer. Look to see if you have the same P. And if there were any ties as you were going through your matrix, it could have come from that. You just pivoted on a different spot, which brought you to a different solution with the same minimization. All right, so now enough of that. Let's talk about reading our answers. Let me copy down. I'm going to stick with this version of the matrix with the pivoting that happened to occur here in the top, where we're going to have the x, y, and p being those values. I'm going to copy those down, and then we're going to talk about it from there. Okay, so finishing up the dual method. Our process was to do the whole write your functions into the matrix, transpose it, pull it back out into equations, then do simplex like normal. And so now this was just doing the standard simplex. There we go, standard simplex, which got us to this answer. Now, the one difference is how you read your answers. Now, normally, we would be using our variables were q, r, and t. But you have to remember, in the original problem, they weren't q, r, and t. Our original variables were x and y, so and then p and equal sign. So those are going to be the things we get our answers from. Now, the next part of this that is just takes a little bit getting used to is how you read your answer is the thing that you want, the variable you want, divided by p. So my x is 1 divided by 1. My y is 3 divided by 1, and then my p-value is 4 divided by 1. And when we say the thing that we want, this is kind of just read like normal. We have 1p equals 4. So there you go. So the answer to this system is we have and also remember, we flipped it. We didn't originally have p, we had c originally because we were talking about minimization. So it really doesn't matter. We just have a min of 4 at 1, 3. And there you go. So that is usually the most confusing part of any of these problems. So what I'm going to do is make up a new solution for us to read, just so we can practice that. So I'm just going to copy and paste this entire matrix, but I'm going to change some of the values just in this solution. Now, what I have done is I have gone ahead and copied the matrix from up above, the exact same matrix, except I just changed my x, my y, my p, and my equal sign values, just so we could practice reading another solution, because the rest of it is very algorithmic and you're already used to it. Just reading this is a little different. Now, the other thing I could point out is, really truthfully, if none of these numbers were here at this point in time, would it matter? Our answer, if that stuff was, who cares what it is? Our answer came from taking this value, this value, this value, and this value, and dividing them. So you don't really need all of it. Anyway, so let's figure out the x value. How you get the x value is your x divided by the p. It's the whatever your value in your x column divided by the p value. So that would be 3 divided by 4. There we go. So then the y value is the exact same thing. It's the y divided by p. So that would be 7 divided by 4. And last but not least, our equal sign would be 2. So our c value would be 2 divided by 4, or aka 1/2. All right, so our answer to this particular matrix would be, we have a min of 1/2 at 3/4, 7/4. Okay, so what is the point of the dual method? What is the point? Let's recap. The point is, if everything is wrong, if this would have to be all, if we were doing simplex, we'd have to start this row, this row, this row, and instead of minimizing, we have to do maximizing, so we'd have to reflect the graph. If you have everything wrong, wouldn't it be a lot simpler just, hey, let's transpose this thing and then do a new problem? But now it's a standard simplex, which is so much simpler, so many less rules, so many less steps. And then just have to remember how to read your answer. Your answer is written a little differently. That's the big idea on dual. All right, see you in the next video.